Welcome to Subsurface. It's a pleasure here to be talking to you. This is the fifth week I'm on the road. We decided to take this event to different continents and different cities. I don't know if that's a great idea, but it's really good to come and see our customers. I have Aniket here with me. He's my lead AI architect, and so what we're gonna tell you today, we're gonna talk to you about this session and the next session is forward-looking. Okay? In 26.1 that dropped today, and the new serverless, the new cloud launch, we have the analyst agent there today, and that's a read-only agent. And we built that out over the past 8 or 9 months. And as we built that out, we've got some early adopter customers, and we've done our own sort of experiments and research, and we learned a few things, and so we experiment with those. And so semantic layer is one of those things that we've learned as we've built this feature set, and we learned the importance of it. So what I'm gonna do is I'm gonna introduce you to the concepts, so we're gonna introduce you to what our strategy is, what we're building. Aniket's gonna come show you a couple of demos of real live working code, but it's still early. And you're gonna see some of these features emerge both in our software product and in our cloud product over the next 3 to 6 months. So let's get started. Now, why is the semantic layer important? So prior to Dremio, I've been here just over 4 years. I was an early employee at a company called Tableau. And I spent 8 years there. And data is different than code. Why am I making this distinction? One of the sort of biggest use cases of AI today is for developers. Use AI, use agent. Code is stateless. You can train the agent to learn the programming language, and it can help you. It's really useful. My devs, 87% of my devs use AI every day. Data, though, is stateful. It has meaning. And today, the meaning traditionally is in a BI platform, or it's in the head of humans, right? Like they understand what the meaning is, and usually the medium to impart that is the BI tools. My belief is that that's gonna compress into the data platform itself, and that's sort of our strategy. That's what we're looking at. And so we've been experimenting with how do we represent that in Dremio, closer to where the data is, so that not only do you have federated access, unified access to all your data, you have your business meaning there too. So that when the humans, BI, SQL, or AI, everybody's kind of working from the same playbook. And so we're gonna be introducing a semantic layer. We're gonna introduce things like entities and attributes and relationships. It's going to be powered by a knowledge graph in the platform. Knowledge graph is the brains of this layer. And it will incorporate things like relationships, which we can infer by looking at your query history. We can look at joins, we can look at filters, so we can infer some of that information. We can sample the data and also sort of derive meaning from it. And you will see a demo where we hydrate this automatically using AI and heuristics, so you don't have to start from scratch. Right? We'll give you a base, we'll hydrate it based on all the sort of assets that are under Dremio's domain, so that's PDSs and views and all the sources that we connect to get you started. But what's most important is the human has to be in the loop, right? No automation is gonna keep itself up to date, and there's no way to sort of understand meaning without somebody auditing and making sure it makes sense. So we're gonna build an experience that's both automated, but has governance and rules where somebody can go in and look and say, okay, I wanna edit this, I wanna add this other thing. And you can then review not only just entities that are in the system, but business metrics, right? That's a gap in our platform, which we're gonna go plug. And you'll be able to then have a governed definition of a business metrics. This use case that I'm showing you is 2 weeks ago. I was in Germany, was customer of ours, Continental Tires, and they have a use case for manufacturing in the plant. And the guy showed me the schema, and you'll see some of that, because we tried to model the demo after it, where it was literally A, B, C, D in German, and columns were like that. And a column could have 4 meanings. It could be the part, it could be the location of the part, and 2 other things I don't remember. And the domain itself was in SAP's inventory management system, which the data engineering team didn't have access to. So then the business user would take a PDF and give it to them, and then they would start a map and build these views, right? And so we can detect some of these metrics, like the overall equipment effectiveness. I don't know what it means, but that's a metric that they have, by looking at the repeated calculations in the history. And then we get surfaced and then said, hey, this looks like a metric. Do you want to save this as a first-class citizen of the knowledge graph? And you can materialize that with a reflection. So now not only do you have a governed metric that everybody aligns with, you get better performance. And then why do agents need this? Right? Ultimately, agents are dumb. Right? They get some instructions, but they don't know meaning. So and we'll show you, show you some statistics here shortly. When we ran some experiments on this schema, like I said, A, B, C, D, columns are all sort of unambiguous. I'm sure a lot of you have seen schemas like this in your professional lives. If I ask that question to an agent without giving meaning, it takes a long time and burns a lot of compute to figure out the answer. It does about 60% of the time get the answer, but it takes a lot of attempts to do it. But on the right, when we introduce the relationships and basically relationships and attributes, it could do that a lot faster. And here's some experiments we ran in our lab. In the first case, for that schema and that question, when there's no semantic layer, it took 144 calls to the LLM APIs. In our case, it was OpenAI. And it ran 74 sampling queries to figure out what we were asking. When we gave it the semantic layer, half the calls to the LLM and less than 90% of the calls for SQL. So what does this translate into, right? Not only do you get performance, right? You get faster responses, you're burning less compute, and you're spending less tokens. So in a nutshell, right, that's the power of the semantic layer. That's the power of the work we're doing to give you confidence and trust, but also you save money if we build the platform the right way. With that, I'm going to invite Aniket up here, and he's going to talk to you about the demo you're about to see.
Thank you, Rahim. So let's get into this demo. So as Rahim said, we modeled this after the extreme use case that we saw in our German customer. The discerning eyes would point out that, oh, this looks like a TPCDS, a TPCH table, and that is correct. That's what we took, and we actually made this extremely fuzzy. And what we started by saying is, hey, using this, if I have the semantic layer, can you go find the top 5 items that customer ordered? Typically something that you would expect from a TPCH-like table. And now if you see, the AI agent is quickly converging on what it is, because he started by looking at this, and then started trying to interact with our semantic layer. This semantic layer is the thing that we are working on. So what you are seeing is a sneak peek, a trailer, if you will, into what is coming soon. And it started trying to look into data sets, then looking at relationships, right? Like which of these tables do I think, based on my semantic layer, are joining to others. And at that time, it is able to identify not just what the tables are, looking at the join relationships, it can actually make out the semantic meaning behind this TPCH table. So with that, he's like, okay, I think I now understand. The LLM is like, I understand what it is. I have identified the tables. Let me go ahead and start sampling a few of these. Once I sample, and this is typically how a thought process in an LLM works. So once I sample, I can go ahead and do a better job at this. While that is happening, let's take a sneak peek at what the semantic layer is all about. So I started by showing that the semantic layer was already there, but how the heck did I actually hydrate it? So here's how you can actually have the semantic layer point it to your data, point it to your data sets, and actually say, go ahead, hydrate. I'm going a little fast here to just make up for the time we lost initially, but the human in the loop and reviewing of the metrics, I'll just pause just for a second. The human in the loop and the reviewing of the metrics that Rahim pointed out is the key over here. In the keynote this morning, Sender also talked about how just within our organization, when you talk about metrics like the financial metrics of revenue and things like that, you have different meanings. And depending upon what your data is and how different data sets are being used amongst each other, you can actually derive and infer those metrics, and then you have your human in the loop to actually look at whether, hey, is this a valid metric? Should I actually go ahead with it and save it to my knowledge graph and go from that point? Let me, oops, I shouldn't have done that. All right. Taking a look at building the semantic layer, that's fine. I'm not going to touch that spacebar again. But yeah, it'll go through in a few seconds again. But to reiterate the point that it is able to analyze the data, review, infer. Oopsie. Processing, yes. OK, there we go. And that is the semantic layer that powers the knowledge graph behind what the demo was trying to show. And Rahim showed a illustration of what that knowledge graph was. So what the knowledge graph was actually able to do over here is say that, hey, I will take a look at I'll take a look at the relationships between this fuzzily named table and the other table, the columns between that, look at the schema, any descriptions that you have, which means that not only am I inferring it, I can also let you overlay any business ontology or glossary that you might have on top of that, and query history on top of that to fine-tune or make my inferences that much better. So here's an example of the semantic layer. I'm illustrating that a semantic layer saw that this was a query that was running in that I saw in my query history. It was able to overlay this, weight my knowledge graph according to that, and with that, the correct SQL was generated on the first go. So while I have been talking and kind of hand waving, the actual number of SQLs that is generated were 2. One for the initial sampling, and second was the final SQL. So with that, let me hand it back to Rahim.
And the screenshot went by really quick. What's going on here?
Oh, is that again?
No, I don't want to show. Where's the next slide?
Oh, and now this.
There we go. So before I talk about semantic models, in the hydration step, what you saw was us mapping all the data available to Dremio, then sort of suggesting what they mean by sampling history and all that. But what's more important, one of the steps that went by really fast is in that Continental Tire use case, they got that PDF that described the data domain. You can upload that too. And then we can use that together with what we found heuristically in the system to enrich the knowledge graph, right? So we are thinking about this from a self-service point of view, right? Like the business user, the analyst, the people that own the domain, they know the meaning. So we want to give tools not just to the data engineer, but the people that are consumers. Then the next piece of this layer is a semantic model. So you've got your physical data, you got your views, now you got your semantic layer where your business ontology or information is there. Now what becomes a consumable unit? What becomes a data product? So the next piece of that is what we're going to call a semantic model. And it's patterned very, very closely after what Snowflake has. They call it semantic views. And all this is a way for you to author a view, but specifically call out a dimension or a measure, a business metric. And then that becomes reusable, right? So if you have multiple views that use different variations, you just author it once, and runtime, we could figure out what it is, and so it becomes repeatable. And in one of the examples, we built a view that was 200 lines of SQL, and with the semantic model, you could condense that to 10 lines. And then not only is that more sort of understandable and easy to author, the agent can do this for you too, right? But it's more performant. And we have another small demo here to showcase that.
This time I'll stay away from the spacebar, I promise, once I make it full screen. So I will rush through this demo a little bit to point out and then pause to point out what the main things are. So the data set for this demo is NFL's play-by-play statistics. And here, what this is showing is that the actual descriptions and the columns, they are not as fuzzy as they were before. But the fact that there are a lot of them, and it's a pretty large data set, it models after the real world, right? And so being able to define a semantic model actually means you are able to define it. In this case, we have chosen YAML as the syntax, but what it is showing is instead of defining in SQL, you can say, I have these 5 dimensions, I have these 8 measures, and this is an expression of the measure. This is complex, which is what real life is. But you get to define it once. So you are actually listing out all the measures, the tables, the relationships between the table once over here. And when I say you, yes, you can do it manually, or you can have the agent do it for you, because agent will build off of the semantic layer that we pointed out earlier. And with this, now we are ready to use it. We have defined a semantic model. Now the agent is aware of that. And when I ask a question pertaining to, you can clearly see I don't understand NFL that much, or football that much, but pertaining to that data, what it actually did under the covers was use the semantic model to dynamically generate a view that is well suited for the question that is being asked, and immediately got the answers back. Even though this is a recorded demo, this was real time. So imagine what you would need to do today if you don't have the power of semantic models. You either have a kitchen sink view, like a really, really wide view, and then you figure out lots of unions very wide, and you figure out how to roll up or roll up or down or things like that. But here, all you are able to do is the same semantic view. In this case, now it is able to go down. The first one was, I think, 2025. The next one was 2024, going even more deeper into these statistics. And it's the same view, the same thing that is now governed in the semantic layer, able to generate right SQL expansions on the fly so that you can get your answers correctly. So just keeping an eye on the time, because I do want to leave some time for question and answers at the end. I'm going to speed this up a little bit further. What this is showing is this is showing more and more powers of being able to use different metrics, which will then. So these are the metrics that are reviewed and kept in. So kept in the semantic model itself, so that you don't need to figure out every time how to do it, and the agent is able to use it directly and generate the SQL efficiently. So with that, I will pass it back to Rahim.
So summarizing, we're going from sort of a physical and virtual data sets to building a semantic layer that captures sort of our business domain and business knowledge, to consumable views that that also capture sort of the semantic meaning. And again, all these pretty slides, right? All that means is, hey, we want to serve you in the best way possible to the best ability that you have. And it doesn't matter if you're a data engineer, data analyst, business user, right? We want to be able to give you the tools that you can use best to serve the work that you have to do and be productive. I think this is it for the slides, right? So with that, thank you for your time.